When you design assemblies with symmetrical or left and right-handed components, mirroring can help save you time. Mirroring rotates the copies of the components 180 degrees and locates them the same distance from the mirror plane as the originals. You can choose whether each component is copied or if a mirrored version is created. You can also change the orientation of components. Here I have a simple assembly consisting of 4 components: a plate, a bracket, a bolt, and a nut. I also have an assembly origin plane visible, as I'm planning on using this as the mirror plane so I can copy the parts to the other side of the plate. I'll switch the assembly to the home view. And then I'll launch the mirror command from the Assemble tab. Component selection is active when mirror starts, and you can select the components in the browser or the graphics window. If you want to remove a component, press the Control key and select the part again. Next, I'll select the mirror plane. In this case, I am using the assembly YZ plane, but you could use any plane or planar face. The mirrored components are previewed as soon as I select the mirror plane. The next step is to define whether I want mirror to create new components or reuse the existing ones. There are 3 status buttons. The green button with the double arrow creates a new component that is the opposite of the original. The yellow button with the plus sign reuses the component. The gray button with the slash excludes the component from mirroring. You typically use exclude on components in subassemblies. Most components are set by default to create a new one, but standard parts like fasteners are set to reuse. You can click on a button to change the status of the selected component, but you can also cycle through the status options by clicking the component button. The preview shows the parts in the same color as their status buttons. When I click the status button for the bracket, it changes to yellow for reuse. Then it disappears for exclude, and it becomes green again for mirrored. I'll set the bracket to reuse so we can explore the orientation options. When you look at the preview, you can see the curved corner of the bracket isn't aligned with the plate. Since the bracket is set to reuse, you can change the orientation. When I right-click on the status button, the orientation options are automatic, and the XZ, XY, and YZ origin planes from the part. You can see how the part position changes as I select the different options. Since none of the orientations work, I'll set the part to mirrored. This time, the part matches the edge of the plate. The next button changes the dialog so I can specify the file names. The file naming dialog has a grid that lists the mirrored components and shows the new name and where it will be saved. I can click in the file name field to change the name. If I try to change it to the same name as the original component, the status changes to Reuse File because Inventor can't create a new component in the same location with the same name. If I either change the file name or select a different location for the file, the status changes back to New File. There are 3 options to modify the file name. The default is to add the underscore MIR suffix. You can also add a prefix or increment the file name. Apply is enabled if you change the settings, and it actually does 2 things. It adds the suffix and/or prefix to the file name, and it updates the default setting. Increment only adds a number if the file name is the same as the original. If you deselect all of the options and click Apply, then the default is increment. You can click Revert to remove the last change. You can also decide whether to place the components in the assembly or open it in a new window. If you choose New Window, an assembly with the mirrored components is created, but it isn't added to the original assembly. If you reuse all of the components, this is the only control on the dialog that is enabled. When I click OK, the parts are added to the assembly. The parts are constrained together, but they aren't constrained in the assembly. This makes sense because parts are usually positioned relative to the model geometry and not a fixed distance apart. If the plate changes, the part position will update to match it. This allows you to position and constrain the parts in the assembly without deleting or editing constraints to the original parts.